Greetings, welcome to APchemistrycourse, and today's lesson I'm going to talk about Lussacs law. Alright, so Lussacs law was uploaded in 1808 by the French physicist Joseph Louis Lussac. So this physicist applied a law that talks about the relationship between pressure and temperature. Alright, so let's get a small story, so we can let's use a small story to understand what's happening. Let's imagine now we have a wheel. You have a flat wheel and you want to just pump air inside it. So we have here the wheel and it's flat. Alright. So you're pumping air into it through the valve. Right, and you notice at first that there is no temperature changing. It's 24 Celsius degrees in the room and the tire feels it's neither warm or cold and everything is normal. What happens as you pump more and more air, pressure is increasing and it's getting stiffer. But when you put your hand on the wheel again to check if it's stiff, it feels hot. But have you ever wondered why does that happen? And isn't it surprising, suddenly you're just pumping air and the temperature around you doesn't change, but the wheel's temperature increases? Isn't that weird? Well, all thanks to Lussac's law, it explains everything. So it mentions in Lussac's law that as pressure increases, temperature will increase, and as pressure decreases, temperature will decrease. So we have pressure increasing. What will happen to its temperature? You're right, it will increase with it. Now let's say the pressure decreases. When pressure decreases, temperature will decrease with it. So what type of relationship is that? You're right, it's a proportional relationship. So as this goes up, as this value goes up, this value will go up, and as this value goes down, this value must go down with it. Alright, so this is about Lussac's law. Let's try to apply let's see the ideology or what's happening here. Then we can apply a small question to understand how to use it. Alright, so what's happening here is that when you're pumping air, you're putting more air particles inside. So you're filling up the spaces that are inside. Now what happens here, according to kinetic molecular theory of gas, we made a video about it last month. It mentions that always gas particles are in constant random motion and they're colliding within each other and within the walls of the container. So there's kinetic energy moving. As we put more gas particles, there's less space for them to move. They have this kinetic energy that they have and they keep on bumping to each other and hitting the walls, so temperature will increase. And this is all because of the space decreasing, pressure will increase. So what happens to the temperature? It will increase. Of course, the volume, it says, for example, let's say the volume here is constant. That's why pressure, we have that volume that's constant. As we put more air particles and there's no space, it doesn't expand more, then pressure will increase. Alright, great. So we talked about the idea and what's happening and why is temperature changing. And it's really interesting, to be honest, because when you think about it, you don't add heat to change it. It's just simply adding air particles to change temperature of something. Alright, so let's take an example and try to apply the formula, because applying the formula is the most important part. Alright, so we have a gas container with a pressure of 300 kilopascals. Alright, that's great. And it's at room temperature. Of course, we all know what's room temperature. Then, if the container is heated or warmed to 60 degrees Celsius, what will the pressure be, or what will the new pressure be? Great, we read it at first. So always the rules that I apply, that whenever I'm reading a question in gas laws or any question in chemistry, I underline what do I see. So it says a container with the pressure of 300 kilopascals. With that sentence, we can tell that it means it started with that much. So the pressure started as 300 kilopascals. That means this is always the first pressure, because it says the container with the pressure of 300 kilopascals. And how can I know that it's a starting pressure? Because as we continue reading, they're asking what will the pressure be after this Celsius increased. Okay, let's continue. I'll explain it. As at room temperature, what does that mean? It means at room temperature, which is 24 Celsius, then this will be our first temperature. If the container is warm to 60 Celsius, that proves that this is T1, because they said that they increased the temperature, so that will have T2 here. Now, what will the pressure be? Always whenever I'm trying to find out the last unit, I circle the given, the ungiven, so you can find the value and remember that we're searching for it. So, from these values, I can tell which one is P1 and which one is T1. How is that? Because it says a container with the pressure of 300 kilopascals and it's at room temperature. If the container is warm to 60 Celsius, what will the pressure be? The first key here, we saw that it says if the container is warm to 60 Celsius, what will the pressure be? That means that we started at 300 kilopascals, we increase the temperature, and the pressure must increase as that, because as we said that we have a relationship, as pressure increases, temperature increases. So that means if temperature increases, the pressure must increase. You're right. So I can tell that we have here P1. For T1, it's really simple, because it says that it's at room temperature. And another thing, it says here, why is that T1? It says it was warm to 60 Celsius. So if we add all of those, we can understand that this is T1 and this is T2. Alright, great. Now let's do the second step. Second step, always put down the givens. So how do you put them down? You always write P1, T1, P2, T2. Alright, now we'll put down the givens. 300 kilopascals as the first pressure or the starting pressure. T1 temperature, 24 Celsius. The second pressure. Oh, we need to find it. So I'll put a line because we don't know what's the answer. T2, the second temperature, 60 Celsius. Alright, so let's continue solving. What do you mean? You're right. As you watched the previous video about Charles' law, we understood that temperature in gas laws can never be in Celsius. It can't be really used. So what is the unit that we should convert it to? You're right, Kelvins. Now, if you watched the previous video, we know how to convert Celsius to Kelvin. And if you want, you can visit the other video and come back, or you can just continue watching the video and I'll show you the formula. So the simple formula, or the simple way to calculate temperature turned from Celsius to Kelvin, is simply writing K equals 273.15 plus the Celsius, or the Celsius unit that we have. So let's start with 24 degrees Celsius and we plug it in. So we have 24 and we add that to the 273.15. Let's not waste time doing it mentally. 273.15 plus 24, and that will give us an answer of 297.15. So this is the Kelvin equals 297.15 Kelvins. Alright, now what about the second temperature? The second temperature is 60 degrees. So we put 60. So we put here now 60. And the answer will be 333. So the second temperature that we get is 333.15 Kelvins. Alright, great. So let's re-plug in everything that we have and we got. So the first temperature says 297.15 Kelvins. Then second temperature mentions, after converting it, it's 333.15 Kelvins. That's great. We got the units that we need and we can start solving. But yes, you're right, we're missing a formula. So let's find out the formula. As you said, we have a proportional relationship. So whenever we're going to have a proportional relationship, the formulas are usually going to be as fractions. So that's the first key point that we should remember. It's a fraction. As you always have a unit of a proportional relationship between two variables, p and t, or any other variable, then we're going to have a fraction. Alright, so we said, or we mentioned, as temperature increases, pressure increases, or pressure increases, temperature increases. So do we have that relationship? So let's put down the formula. Always remember, it's temperature, pressure. So we write pressure up, temperature down, pressure up, temperature down. So P1 over T1 equals P2 over T2. That's really great and simple. So it's really simple to memorize, and you will never forget it, as it's a fraction because it's a proportional relationship. Alright, so let's start solving. Now when we're solving, we first thing need to rearrange the formula. Always we need to rearrange it to a formula that it's compatible for our unknown answer to calculate it. So our unknown answer here is P2. We want to solve for P2. What do we do? Always when we're solving in mathematical way, what are we going to do is always leave the unknown variable in one side of the equation and the other variables to the other side of the equation. So T2 is under as a fraction or division, so to break that we multiply it in both sides, so we can take it to the other side of the equation. So T2 cancels T2 out, and we're left with P2. So can we rearrange the formula? Yes, we can. To rearrange the formula, what we got, that P2 is on its own, it's on one side of the equation. Then we have T2 multiplied by P1 over T1. That's great. So now let's start solving for the question. So let's start solving. To solve this question, what are we going to simply do is plug in the data. So first thing, P2 is unknown. We put P2 equals, what is T2? T2, as we got, it's 333.15 kelvins multiplied by the fraction of P1, which is 300 kilopascals. Then what is T1? Of course, we got this, we got this, we got that, we're left with T1. What is T1? T1 is 297.15 kelvins. Great, we got everything. Now let's cancel units. Kelvin because it's up and Kelvin because it's down, they cancel each other out. What unit are we left with? The last unit. We only have 3 units in this. You're right. We have that pressure unit. In that way, we can tell that we're doing something right. We're searching for the pressure. So in order to do that now, we do the math. So we write P2 equals, we do the math now, and we start calculating. Alright, so 333.15 multiplied by 300 divided by 297.15, and that will give us an answer of, you're right, as you guessed, it's going to be 336.34. What's the unit? You're right, kilopascals. So we can see here that as we increase the temperature, the pressure increased, because we started as 300 kilopascals and we ended up with 336.34 kilopascals. So it's a really simple concept. So let's do a small revision or a quick revision. We talked about the relationship between the pressure and temperature, as they are a proportional relationship. As one variable increases, the other variable must increase. So as temperature increases or as pressure increases, the other variable must increase. And if one of the variables is decreasing, then the other variable must decrease with it. So this is all about Lussacs law, and I hope it is useful. So don't forget to watch other videos about the gases. I made a playlist and it's going to be really interesting. So this is all about our video for today, and I hope it was useful. I have other questions that are going to be uploaded in a quiz link, and you can test yourself there. So this is all about our video for today, and I hope it was useful.